Section 5 of the Science, History of the Universe, Volume 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Rick Vina. The Science, History of the Universe, Volume 2, edited by Francis Rolt Wheeler. Geology. Chapter 3, Geology and the Church, Part 1. The decline of the Roman Empire, while, as has been seen, it did not prevent the growth of the adventurous spirit, was a sore blow to scientific study. Life was too insecure to permit leisure, and the governmental situation was uncertain in all countries. From the middle of the 8th century onward, for some 500 years, the Arabs alone kept alive the feeble flame of interest and researches into the secrets of nature. With great labor and at large cost, they procured as much as they could obtain of the literature of ancient Greece and Rome, and studied and translated into their own language the works of the best writers in philosophy, medicine, mathematics, and astronomy. They were thus able to some extent to enlarge the domain of these subjects. But geology was a subject to which the students of the caliphates never took kindly. Albert the Great, 1205 through 1280 A.D., the most learned man of his time, mentions that a branch of a tree was found on which was a bird's nest containing birds, the whole being solid stone. He accounted for this strange phenomenon by the vis formativa of Aristotle, an occult force which, according to the prevalent notions of the time, was capable of forming most of the extraordinary objects discovered in the earth. One of the keenest observers, whose opinions have been recorded, was the illustrious painter, architect, sculptor, and engineer Leonardo da Vinci, 1452 through 1519. His attention having been aroused by the abundantly fossiliferous nature of some of the rocks in northern Italy, in which canals were cut, he concluded that the shells contained in these rocks had once been living on the sea floor, and had been buried in the silt washed off the neighboring land. He ridiculed the notion that they could have been produced by the influence of the stars, and he asked where such an influence could be shown to be at work now. But he pointed out that besides the shells, there were at various heights terraces of gravel composed of materials that had evidently been rounded and accumulated by moving water. The Neapolitan Alessandro degli Alessandri, 1461 through 1523, mentions petrified conchiglia in the Calabrian mountains, and ascribes their presence to an inundation of the continent by the ocean, caused by some exceptional catastrophe or by a change in the axis of rotation of the earth. Fracastoro, in the year 1517, gave clear expression to his convictions about fossils, which were in accordance with those of Leonardo da Vinci. During the building of the citadel of San Felice in Verona, the workers found fossil mussels in the rocks, and laid them before Fracastoro, begging him to explain the marvel. Fracastoro repudiated the doctrine of a vis plastica in the earth as impossible, and just as little did he give credence to the view that explained fossils as creatures left by the great flood. The flood, he said, was of short duration, and in the nature of things it would have left not marine but fresh-water mussels behind. Further, on the assumption that the mussels had been carried from the ocean to the land by the flood, their remains would have been scattered over the surface of the land, and would not have been buried deep in the earth where the quarrymen had found them. There was left, he continued, only one possible explanation, that the fossils were the remains of animals which had once lived in the localities where their remains are now embedded. Far more illustrious than the majority of his contemporaries in science was George Bauer, better known by his nom de plume of Agricola. Werner calls him the father of metallurgy and the originator of the critical study of minerals. Agricola's observations on crystalline form, cleavage, hardness, weight, color, luster, etc., have served as a model for all subsequent descriptions of minerals. On the other hand, Agricola's remarks about fossils are of much less value. He had devoted little attention to the fossil remains of animals and plants, and he unfortunately united under the name fossilia both minerals and petrified organisms. This use of the term fossils was perpetuated for 2 centuries in the literature, having been more especially adopted by the famous Wernerian school. Giulio Cardano, 1552, pointed to fossil shells as certain evidence that the sea once covered the sites of the hills. His contemporary Mattioli, on the other hand, supported the old figment of the materia pinguis, though admitting that porous bodies, such as the bones and shells, so abundant in Italy, might be turned into stone by being permeated by a petrifying juice. He is said to have been the first writer who published a reference to the fossil fishes of Monte Bolca. The skillful anatomist, Gabriele Fallopio, 1562, when he met with bones of elephants, teeth of sharks, shells, and other fossils, refused to admit them to be anything but earthy concretions, because he deemed that to be a simpler solution of the problem than to suppose that the waters of the deluge could have reached as far as Italy. Olivi of Cremona, in 1584, writes of the fossil conchiglia of the famous calceolarian collection in Verona as mere sports of nature. Michel Mercati prepared good illustrations of fossil bivalves, ammonites, and nummelites in the museum of Pope Sixtus V, and these were published between 1717 and 1719 in the Metalloteca Vaticana by Lancisi, the physician of Pope Clement XI. Mercati names the fossils according to Pliny, and after long discussion comes to the conclusion that they took origin under the influence of the stars. It is astonishing to find how tenaciously, until the middle of the 18th century, so many authors clung to such absurd ideas, even although the fossils were being made known by means of good illustrations to an ever increasing number of observers. The works of Aldrovandi, Athanasius, Kircher the Jesuit, Sebastian Kirkmeyer, Alberti, Balbini, Geyer, Hartley, and many others in the 17th century contained good figures and extended the knowledge of the fossils found in various European localities. The fossils were, however, treated usually as mineral curiosities, or as illusions of nature, sometimes as forms called forth in the earth by vis plastica, or some other force, sometimes compared with living mussels, snails, sea urchins, and plants, and named accordingly. In the crowd of writers who took part in the long geological controversy, by far the most illustrious was Nicolas Steno (1631 1687). Born and educated in Copenhagen, he traveled to Leyden, Paris, and Austria, and eventually settled in Florence as physician to the Grand Duke Ferdinand II. While here, he renounced Protestantism for Romanism. Shortly after this, he was persuaded to return to his native land, where his religious beliefs caused him so much unpleasantness that he went back to Florence and was made a bishop. He wrote much on theology and anatomy, but it is his writings in geology which won for him the high position among scientists accorded him by posterity. In 1669 there appeared in Florence his treatise De solido intra soliam naturaliter contento, which must be regarded as one of the landmarks in the history of geological investigation. In this he says that the strata of the earth are such as would be laid down in the form of sediment from turbid water. The objects enclosed in them, which in every respect resemble plants and animals, were produced exactly in the same way as living plants and animals are produced now. Where any bed encloses either fragments of another, and therefore older bed, or the remains of plants or animals, it cannot be as old as the time of the creation. If any marine production is found in any of these strata, it proves that at one time the sea has been present there, while if the enclosed remains are those terrestrial plants or animals, the sediment must have been laid down on land by some river or torrent. Steno's treatise stands out far above all the writings of his own or of previous generations in respect to the minuteness and accuracy of his observations of nature, and the originality and truth of most of the deductions which he drew from them. He was the first clearly to perceive that the strata of the earth's crust contain the records of a chronological sequence of events, and that the history of the earth must be deciphered from them. He laid down for the first time some of the fundamental principles of stratigraphy. Another notable Italian writer, Anton Lazzaro Moro, appeared in the first half of the 18th century. A large part of Moro's work is devoted to a destructive criticism of the cosmogonies of two of his contemporaries. He discussed the possibility of explaining the position of fossil shells in the mountains by reference to the Noachian deluge, and dismissed this supposition as untenable. After giving an account of the uprise of a new volcanic island in the Greek archipelago in the year 1707, of the appearance of Monte Nuovo near Naples in 1538, and of the recorded eruptions of Vesuvius and Etna, and starting with the proposition that the fossil shells are really productions of the sea, he proceeds to unfold his theory that the position of these shells and the origin of the rocks that enclose them are to be assigned to the operation of volcanic action. In the beginning, he says, the globe was completely covered with water, which was then fresh and perhaps not more than 175 perches in depth. No prominences diversified the smooth, stony surface of the globe which underlay the water. On the third day of creation, however, when it pleased the Almighty to reveal the solid earth, vast subterranean fires were kindled, whereby the surface of stone was broken up, and huge masses of it began to appear above the water, so as to form the land and mountains. These disrupted masses, while rising, or after they had risen, and in some cases even before they appeared above the water, were rent open by the violence of the subterranean fires, and they discharged from their orifices vast quantities of material, such as earth, sand, clay, stones both solid and liquid, metals, sulphur, salts, bitumen, and every kind of mineral substance. Part of this material flowed in river-like streams down the sides of the mountains into the water below, part fell in showers from the air, into which the ejected detritus had been hurled by the impetuosity of the fire. The saline and bituminous ingredients now began to give to the water the salt and bitter taste which the sea has retained ever since, while the other insoluble substances formed a new bottom above the original stony surface. As yet no plants or animals existed, but while the water continued to grow more saline, plants began at last to appear both in the sea and on land. Animals too entered upon the scene, first in the sea, living in the soft sand and among the debris cast out by the mountains, and seldom wandering far from their native places. The dry land became covered with verdure and gave birth to terrestrial animals, finally followed by the advent of man, who then took his place as an inhabitant of this first and most ancient land surface. In course of time, the same sequence of events continuing, new mountains emerged from the bosom of the earth, and like their predecessors, vomited forth fresh materials, which were once more spread out over the floor of the sea and the surface of the land. The strata that were thus deposited in the sea would contain marine productions, while those formed on the land would preserve terrestrial remains, including articles in metal, marble, or carved wood, as relics of a human population. Some of these land surfaces, remaining long exposed to the open air, were covered with new strata, which, when they differed in composition from those buried below them, would produce plants and animals distinct from any of those which had previously existed on the same sites. And since the newer strata were not all laid down universally and at the same time, but successively during the course of centuries and at different seasons of the year, seeds and fruits in mature and immature condition would be entombed, as may be illustrated by many examples that have actually been obtained from excavations, in which, at different levels, old soils represent inhabited and cultivated surfaces of land. Morrow had to take care that his cosmogony did not contradict, but only supplemented the orthodox reading of the first chapter of the book of Genesis. The following semi-tragic, semi-comic event was a decided setback to the prevailing belief in the theory of the direct origin of fossils, that is, that they were imitations produced in the rocks by some unknown causes. Johannes Bartholomew Berenger, a professor in the University of Würzburg, published in 1726 a paleontological work entitled Lithographia Würzburgensis. In it a number of true fossils were illustrated, belonging to the Muschelkalk or Middle Trias of North Bavaria, and beside these were more or less remarkable forms, even sun, moon, stars, and Hebraic letters, said to be fossils, and described and illustrated as such by the professor. As a matter of fact, his students, who no longer believed in the Greek myth of self-generation in the rocks, had placed artificially concocted forms in the earth, and during excursions had unveiled the credulous professor to those particular spots and discovered them. But when at last Berenger's own name was found apparently in fossil form in the rocks, the mystery was revealed to the unfortunate professor. He tried to buy up and destroy his published work, but in 1767 a new edition of the work was published, and the book is preserved as a scientific curiosity. Many of the false fossils, Lichtenstein, may be seen in the mineral collections at Bamberg, and there are also specimens in the university collections of Würzburg, Munich, and other places. Palissy, a French writer on the origin of springs from rainwater, and of other scientific works, undertook in 1580 to combat the notions of many of his contemporaries in Italy that petrified shells had all been deposited by the universal deluge. He was the first, said Fontenelle, when in the French Academy he pronounced his eulogy nearly a century and a half later, "Who dared assert in Paris that fossil remains of testacea and fish had once belonged to marine animals?" Palissy's ideas were violently attacked by his compatriots, and he was denounced as a heretic in his philosophical and scientific writings, just as he was a Huguenot and a heretic in his religion. Section 5.